Sir, shall I start, sir?
Maybe after 1 more minute we can start. It's already 1:59.
Okay, sir. Right.
Many are joining now, I think. Yeah.
Yeah. Sir, can I start now?
Yeah, you can start. Yeah.
Yeah. Very good afternoon to all the participants. I once again welcome you all for this day one session two AICT sponsored short-term training program on IoT and artificial intelligence in smart communication networking. I hope the day one session one went well, and it is. I hope all of you have learned some new things from Professor Prashant sir. I request Professor Prashant to continue in the field of 5G. He is going to take this session to give another excellent lecture. I request you to kindly you can start, sir. Start your lecture.
Yeah. Thank you, Dr. Thank you, Dr. Swaminathan, for this kind introduction. Today, the afternoon session is primarily focused on just providing a general overview of 5G technologies. So, as mentioned in the morning, I will only be. I'm not looking at any research issues. This is a primer. Both the talk in the morning also is basically a primer, giving you a broad overview on the concepts of IoT. The same will be happening now. I am just going to give you an overview and a primer. I am not going to delve into research issues. But if you have any queries on research issues, I can always answer in the Q&A session. Before I start, I thought I'll just give you a quick a summary of what we covered in the morning session. Just to give you a summary, in the morning we started. I told you started with why we need to go for IoT technology. So I was stressing on the need for Industry 4.0. The reason is today, the smart factory, the smart manufacturing, Industry 4.0 is the norm. All enterprises are moving towards Industry 4.0. That is the same as smart manufacturing, smart factory. I also told you that the building, the smart factory or the Industry 4.0 is based on cyber physical systems. Cyber physical systems are, systems where humans and things and devices collaborate, communicate with each other, creating, virtual processes that interact with the physical processes and also collaborate and amongst themselves. So if you take a port, a port, there is a ship. Ship is a physical process. There is a berth. Berth is also physical. There is unloading and loading of goods in the port, physical. But all these are also monitored in a digital level. So there is a digital twin of this entire physical process in the form of a virtual process. And there is an interaction between the virtual process and the physical process. So that forms what is known as a cyber physical system. Now, I also told you about the what are the basic building blocks of the cyber physical system. The cyber physical system has five major building blocks, starting with IoT, which is the most important building block of the cyber physical system. Then I told you that the other building blocks are 5G, which I'm going to cover now. I also told you about robotics, sensors, and finally artificial intelligence and machine learning, which forms the other building blocks of the cyber physical systems. Then I gave you an overview about the different aspects of IoT, how we evolved from machine to machine or peer-to-peer systems developed into IoT, because peer-to-peer means there is only some sort of communication and content sharing, but content and communication is there. But in IoT, when we move from M to M, machine to machine, we move to a higher level where we are talking of content, of the context. Context is the situation or the ambience or the environment, so as to speak. We are talking of collaboration between all these elements. We are talking of cognition, the cognition, and we are talking of the cloud. The cognition is nothing but the analytics out of it. We are able to take decisions. We are able to get insights out of it. So I told you that we are moved from M to M, machine to machine systems, to a much higher level, which is known as the IoT. And the IoT is this thing. Then we looked into various aspects of IoT, which include the various the 7 layers of IoT. I looked at the 7 layers, what are the various building blocks, and how is IoT formed. IoT, the things that make the IoT are the sensors, which sense, are the actuators, which do some actions or which act, the cloud, which does the storage, and the hardware and software. So that's pretty much what I covered in the morning. In the morning, I also told you about the importance of the big data. I told you that the big data is a very important thing in the sense that we are now living where in an age where there is so much of big data, and the big data is created as a result of a lot of what should I say, data being created. Now I told you, in a very interesting number I told you was, see, today we have a population of around 8 billion people in this world, and there are already 50 billion smart devices, which IoT or whatever, smart and intelligent devices. So we are looking at something like each person is having something like 6 different devices, and that number is only going to increase. It's not going to reduce. It is going to increase. It may happen that one person may have 10 different smart devices or this thing. So you can imagine what the technology landscape is there in the future. And when you look at this technology landscape, when you're looking at 6 devices per person moving on to 10 devices per human being, you are looking at that amount of big data. So much of data is going to be created. So much of data is going to be stored. Now, when the data is created, there is a whole lot of things that we have to do to the data. We need to first collect the data. Collect the data. Data comes from many sources. I told you, everywhere there is a car has, say, 5 sensors or 100 sensors are there. Car is giving 2 terabytes of data. You have 2 billion users of Facebook. The 2 billion users of Facebook, you can imagine if 200 or 300 million of them are posting every day, you can imagine the amount of data that is there on Facebook. Terabytes of data is happening on Twitter every day. So much of data is coming, sensor data, social media data. And this is going to be the biggest challenge for IoT, cyber physical systems, Industry 4.0. Because the data is going to come from so many sources. Now, you need to use this data. You need to collect this data. So many sources are there. And mind you, this data comes in all hues and sizes. Different formats, almost 100 different types of formats. Some may be video, some may be audio, some may be documents, some may be XML, HTML, different formats, PHP. 100 different formats of data, and mostly this data is unstructured. It is not available in a structured fashion. It is in a very unstructured fashion. So this is probably going to be the biggest challenge of the industry 4.0, and we will need to collect the data, collate the data, clean up the data, collect, collate, consolidate, clean up, visualize, and then use the analytics to convert this data into information, and information to knowledge, and knowledge to intelligence, so that we are able to take decisions. We are able to get insights into that data. So IoT, cyber physical systems, AI, industry 4.0 will bring a biggest challenge that we are going to see is going to be the problem of big data, and how do we solve this big data is going to be the biggest challenge of all. So today we are going to, now I am going to give you an insight into the other major enabler of cyber physical systems, namely the 5G technologies. This is just a basic overview of the 5G landscape. Is my slide visible? Is the slide visible?
Yes, Professor.
Yes?
No.
Can I get a affirmative?
Now it is. No, now it is available. Yeah, it is available.
Yeah, okay.
It is visible.
Yeah,
It is visible.
thank you. Basic.
1 minute, Professor.
Yeah,
1 minute. I request the participants kindly please pin Professor Prasant presentation. Those who have logged in via system or laptop, please kindly pin Professor Prasant presentation. Thank you. Sir, you can continue.
Yeah, thank you. Yeah, so as mentioned, I'm just going to give you a broad overview of this 5G. I'm not going to delve into any research issues. So if you have any research issues, there is no problem. We can discuss. I mean, if you have any queries regarding the question answer, we can. This is only a primer. This is only a basic overview and primer of 5G and what are the technologies that are behind 5G and so on and so forth. It is not moving. So what is 5G technology? 5G generally stands for fifth generation wireless technology, and it is a complete and comprehensive wireless communication protocol and technology where we can leverage the power of the wireless for all these various applications that I mentioned. And there is tremendous speed, tremendous quality of service, tremendous throughput as a result of 5G. Now, the concept is not only theory, it is real in the sense that today we are actually in a state where 5G is available, but not in a commercial fashion. 5G is available in a test bed, this thing. Some cities in the world, very few cities, Berlin and all, some 5G commercial services have been rolled out. But in India, we are yet to see commercial services rolled out. So by and large, across the world, 5G is implemented. It is working very well, but it is yet to be, commercial rollout. But let us see what this fifth generation technology is. So the current status of 5G is that the European Telecommunication Standard Institute is formulating 5G global technology standards, and most of the telecom companies like Nokia, Ericsson, NTT, Docomo, Samsung, Huawei, Fujitsu are all in some sort of agreement with regard to the various protocols, with regard to the bandwidth, with regard to the various aspects of the 5G technology. So it is in one state where most of the telecom companies, and I want to here again make a note that Apple is not yet clearly given its what is that? It's a little hazy in terms of whether the Apple phones that will come subsequently will be compliant. There is some now some sketchy details have only come, but they are not part of this alliance, which is driven by most of the telecom companies which are primarily based in China, Japan, and Korea, Taiwan, and of course their ancillary industries are here. So all of them are more or less in agreement with respect to the 5G rollout, and the European Telecommunication Standards Institute is formulating. Now, even in India, at least the nodal agency, the ministry is very much on board. There are 5G test beds happening in all over the world, including India, UK, US. Some companies like Apple are still holding out. They want to probably negotiate. But at the end of the day, since the entire world is going into 5G and the protocols are being decided by the European Telecommunication Standard, definitely everybody will have to comply, and Apple will also have to come on board with respect to the 5G rollout, the protocols, the standards, and so on. Now, there is a catch with respect to 5G. At presently, most of the phones that we are using, majority all of the phones that we are using will not be able to work on 5G. But the ulta is possible. When you are buying a 5G handset, new chipsets will be given, because the speed for 5G will be phenomenal. It will go up from 10 gigahertz maybe to 50 gigabits per second. 10 GB to 50 GB is the likelihood, depending upon the test bed, depending upon the building blocks, the enabling technologies. Here and there, multiplexing and all slight differences are there in different rollouts. But when the 5G rollout happens, we are looking at minimum of 10 Gbps to 50 Gbps. And the present mobile phones that we use, the chipsets cannot manage that kind of bandwidth. And for sure, we will have to replace these with better or faster, better this thing. But the ulta will be possible in the sense that you buy a 5G phone, it will be definitely possible that the 4G and the 3G services may work. That is what I am given to understand. So the concept of a global village will come because of 5G rollout. There will be global worldwide cellular phones all over the world. You can use the handset. There will be no problem. Even now, I remember the first time I went to the US in 2003. I went for a 4 months or 6 month assignment for officially from our university, and I remember mobile phone was a big problem. My mobile phone could not work because it was not a tri-band or a quad band phone. The entire band was different, in the sense that the phone does not work because the technology is different, the handset is different, and I had to, borrow a phone from a friend for the 3-4 months that I was there. It was very difficult. Of course, I've been regularly going, maybe 5-6 times I've gone. If I remember, the last time I was in the US was in 2018. There was no problem. The Apple phone was perfectly working, and I didn't have to do anything. I just have to talk to the BSNL fellow, and when it goes to the US, it becomes Verizon wireless, and automatically the phone was working. So now those things are of the past, but then still some countries there may be some issues. Anyway, when the 5G rollout comes, these cellular phones will be available throughout the world. There will be very good connectivity. There will be low power usage, large phone memory, better speed of dialing, better clarity of audio and video, and extraordinary data capabilities. Now, here I want you to appreciate why this is so important. I told you that, Industry 4.0, we are looking at smart factories, smart manufacturing, smart logistics, smart education, smart health, smart cities, smart buildings, smart car. Everything is getting smart. And in such a regime where every activity that we are doing is using smart technologies and so on, we will need to have very good, extraordinary data capabilities. And that promise the 5G will bring. In the sense that, you are having a mobile phone, you may be checking data, mostly you may be using the mobile phone for using data. Now, I want you to introspect on one aspect that, it's a very interesting thing. If you see in the last, say, 5 to 7 years, the usage of your computer, of course, all of you are faculty members, you are using the computer for various purposes, primarily maybe making lecture notes, giving assignments, showing videos, taking classes online, all that stuff is there, doing some programming. But if you ask yourself, how much of the time you are actually using the computer for computing? Ask yourself, how much time are you actually using the computer for actual computing? It may be very little amount of time. How much time are you using the computer for doing C programming? Maybe 2%. You see, as a computer science professor, I may be probably using the computer for computing maybe 10 to 20% of the time. Remaining 80% of the time, I am not using it for computing. I am using it for other purposes. So the very concept of a device, it is called a computer. But is it really computing, or is it using for other things? We are using it for every other thing other than probably computing. As a computer science, maybe I am a little more this thing. Maybe if you are an electronics professor, it may be even lesser. If you are a mechanical engineering professor, it may be even lesser. So even the name computer is today a misnomer. Is it right to call it a computer? We are using it for watching movies, entertainment. We are using it for taking classes, communicating. We are taking it for watching movies, entertainment. We are using it for stockbroking, business, e-commerce. So the name itself sounds to be something like a misnomer, whether it is actually used for computing. Same with the mobile device. At one point of time, we were probably using 10 years back or 15 years back, the mobile phone we were using primarily for voice, right? And we were having a little data in the form of an SMS or a short messaging service. This was primarily. Now, if you see the usage of a mobile phone, the voice has come down and the data has become much more heavier. The data has taken prominence over the voice. We are probably using it, maybe 10 or 20% of the time to speak. We may be using it for WhatsApp. We may be using it for all the other computing requirements that we need. We are attending meetings on the mobile phone. We are doing purchases, e-commerce on the phone. So whether, the actual functionality of a computer and a mobile phone have completely evolved over time. And because of that, it requires all these things, that is extraordinary data capabilities, speed, power, better power consumption, better connectivity, more storage, more speed, and so on. And that is the promise that 5G has to offer. 5G will provide all that in the palm of your hand. Now, if you see the market growth, again, this is perhaps pre-COVID times, it might have changed. The numbers have only probably increased. This is a forecast that today, in the morning, I told you 7.83 billion people are there on the planet, around 8 billion population of the planet. Maybe the forecast was to have 4.6 billion mobile phones. Perhaps it may have peaked more. It might have been much higher today. and maybe around 20 billion. So we probably today have, I'm not very sure, but we probably today have something like 5 billion mobile phones. Out of that, almost all of them, perhaps 95% or 95% may be smartphones, 5 to 6 billion phones, almost all of them smartphones. We probably have 20 billion SIM connections. One person can have 1 or 2 or 3 connections. So we are looking at a huge market. In terms of SIM connections also, it could be somewhere like 20 billion. And today, mobile market all over the world is doing very well. India is perhaps the largest mobile phone market in the entire world, even higher than China. Higher than China, India is probably the biggest mobile market in the whole world. People are, increasingly hooked onto their mobile phones, for using it primarily for other purposes than voice, primarily for data, connectivity, and so on and so forth. Again, these numbers are probably pre-COVID. The number that is saying that it could be, we could be using something like 2.5 gigabytes of data per day per customer. It's again a very, it's a prediction. We could, all these were pre-COVID predictions, and definitely the traffic as far as the mobile phones are concerned will be much higher in emerging economies. Developed emerging economies like India, China, and all, there the penetration of mobile phones, the number of SIM connections, the internet users will only increase. It's much more, what should I say, much more heavy with respect to emerging economies, other than this thing. So, as I mentioned before, India is the largest mobile market in the entire world. The whole world, India is perhaps the largest mobile market. Yeah, so same thing, these slides only kind of reinforce that thing that, we are going to have more and more smart devices. We are going to have more mobile data traffic coming from video, and all this will require high-speed video, high-speed streaming services. All this will require the 5G rollout. So the 5G, the promise is very, very good. It is an end-to-end ecosystem to enable the fully mobile and connected society, a connected society, a smart society where everything is smart, which could be your car, which could be your smart healthcare, it could be your smart factories, it could be your smart homes, smart buildings, smart cars, smart factories. So 5G is a very, very important enabler of all these things smart. So this slide tells you the relevance, the importance of why 5G is needed in this situation, in this regime. We need to have 5G because only then the data communication with respect to all the things that are smart, whether it's your home, your computer, your clothes, your shoes, your education, healthcare, everything is being affected. And what will happen because of the 5G rollout? We are going to see 1,000 times more data volumes. We are going to see 100 times more devices. Now, I already told you that perhaps today we have 50 billion devices for the 8 billion folks. This may increase into 10 or 20 per person. The number may 10 times to 100 times the number of devices are likely to increase. So we are going to probably see each human being having 10 or 20 or 30 or 50 devices, depending upon the type of person, the kind of job, the kind of vocation, and so on. So, and these devices are going to be fast, these devices are going to be effective, they're going to have a lot of capabilities because of the 5G rollout. So we moved from 1G to 5G. We will quickly, before getting into the 5G, we will quickly look at the various technologies that brought about this transition to the 5G and its rollout. So starting with 1G, 1G was developed in the 1980s and completed in 1990s based on a complete analog system with a speed of 2.4 kbps. You can't even imagine what that speed was today. And it was launched in the form of an AMPS, Advanced Mobile Phone System. And we could only make voice calls in that country. It was not possible until calls anywhere. And suppose you wanted to talk to somebody in the US, you need to use a trunk call. You need to book a trunk line. I'm sure some of you may or may not have remembered those times, but at least I remember when we were abroad, I remember my mother or my father wanted to talk to somebody in our hometown. We had to book a trunk call. That was the only way to talk to people who are abroad. But that was the first rollout between 1980s to 90s, an analog system with speed of 2.4 kbps. Then we moved to the first digital system, that is the 2G. This was developed in the late 1980s and completed in late 1990s. A complete digital system where we were able to get a speed of up to 64 kbps. Other things we could have was digital voice, SMS facility was there, some data facilities were there. We could use some limited voice over IP and certain things were there. And it was a semi-global facility. Some countries where the technology was, I think if I remember right, there were GSM and CDMA. The countries that were using CDMA, your phones could work. If you're going to, say, Europe, India started with GSM. So if you are going to Europe and all, it would work. London, Paris and all, it would work. But it wouldn't work in US because US was primarily CDMA technologies that were designed by Qualcomm. So that time, this was the situation. And the basics handsets that at least the major technology that we use today were based on the 2G, the 3G and the 4G rollouts. So both 3G and 4G are essentially the same architecture, but improvements over the 2G. 3G phones are even today available, developed between the early 2000s. The speed increased up to 2 Mbps, somewhat good voice quality. We could do some computing facilities were there. We could use emails, we could check the web, we could do some online shopping, e-commerce, and we could have global roaming. You had a global roaming 3G quad band or tri-band phone. You could go anywhere in the world and use the same mobile phone, just change the service provider. Today the handsets that we have, 3G and 4G, are essentially based on the 2G only. Of course, now we are all in this 4G, the spectrum thing. We are developed, it's almost a decade of using 4G, faster and mobile, more reliable, up to 100 Mbps speed, high performance, easy roaming, low cost. Now, in between and all, you might have seen newspapers and advertisements talking of 5G and all, but they are actually not 5G, they are all 4.5G in the sense that if some companies are telling that we have implemented 5G and all, it is not right. It is basically 4.5G, where they have added some value-added services to the 4G. But it is not 5G service. 5G service is a totally different thing. It requires a new mobile phone, a new chipset. It requires a totally different band. and so on. So if at all some companies have been claiming that they have rolled out 5G services and all, it is only marketing. Actually, it is nothing but 4.5G. Even today, many cases we are in 4.5G. To be very honest, we are in 4.5G. In most of the service providers are doing like that. Yeah. Now I already told you this. This is going to be the next phase of the mobile telecom revolution. 100 times more capacity, high speed of 1 Gbps. Actually, it's not 1 Gbps. It is much more reliable than, and so on. So this slide, I'll give you a minute to look into this slide. This gives the how the difference has increased from 1G to 5G, where we moved from 2 kbps kilobytes per second. Today we can go up to 50 gigabytes per second in 5G, and we have a whole lot of value-added services. We started with only voice, then it moved from data to voice with limited data, more voice and limited data. Now we have come to a completely different paradigm, completely digital, much more heavy on data, very less on voice, and so on. So this is just a quick slide on the various aspects of the transition from 1G to 5G. Yeah. One important thing about 5G services is that I already told you we can enable high-speed data communication, high-speed transmission, high throughput, high quality of service, and we can use it for all things smart. We can use it for wearable devices. It is one unified global standard. We can use it for software-defined networks, SDN. We can use it for software-defined radio, SDR. All these are possible. But one more issue other than the chipset, as I mentioned, we have to use different chipsets. We have to use different mobile phones which are enabled for 5G. One more catch which will come from the 5G revolution is the fact that we will have to completely transition to IPv6, Internet Protocol v6. Today we are somewhere between IPv4 and v6. We are transitioning to IPv6 networks, but completely speaking, that transition has not happened. We have not completely transitioned to IPv6. But when the rollout of 5G services comes, it will be necessary that networks will have to be upgraded onto to IPv6. Now we will see some of the technologies, the protocol stack of 5G. In the morning, we saw the protocol stack of IoT. I'm explaining with the same example, the example of the ISO oversight model, which I told you, international standards organizations, open system interconnection model, where we start from the physical layer, move to the data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Here the protocol, here it is very clearly mirrored, but with different, albeit with different names. Now you will also notice that many a place there is open. Why is it open? Is because multiple handset makers, multiple service providers are there. I mean, in India itself, you buy mobile phones from Samsung, from Nokia, from Apple. Same way you have different connections. You have BSNL, Jio, so many service providers. So, but the 5G rollout is open in the sense that the open OWA, open wireless architecture, and open transfer protocol, both the layers are generally interoperable. That is the idea. I told you in the earlier slide that most of the major companies like Nokia, Samsung, Huawei, Fujitsu are working together for this. And that working together is to ensure that the counterpart for the physical and data link layer, that is the OWA, open wireless architecture, is very much the same. Then we have lower network, upper network layer. The network layer is divided into two. The session and transport layer are combined into OTP or open transport layer, and the on top the application or the service layer with the presentation and application. So here we are seeing there is a one-to-one mapping with respect to the ISO OSI layer and the 5G rollout. Yeah, going much into the detail, the OWA or the open wireless layer combines the physical and the data link layer of the ISO model. And here it is open wireless architecture. All the mobile phone companies which are manufacturing the chipsets and the handset and the chipset manufacturers will ensure that this physical layer, there is some sort of interoperability, whatever be the technology they are using. That is why it is the OWA or open wireless layer. Now the network, as I mentioned, there is one issue that we are going to face, that we will have to completely move on to IPv6. We cannot be in a transitioning phase. We have to completely move to IPv6. It will have to be implemented, and there will be mobile IP will also be implemented. A mobile can be attached to several mobiles or wireless networks at a time. A mobile will become something like a router, just to give you a simplistic example, a mobile will function like it is like a wireless router. Even today you can tether your phone and get internet connectivity, but similar to that, you can imagine that every mobile phone can act like it is a router or a access point. Something like that will come because of the high bandwidth. And the earlier network layer is now here, it will be divided in for one part for the interface and one part for the terminal. So that is why it is a lower network layer for the interface and upper network layer for the mobile terminal. Now, in the OTP or the open transport layer, there will be a change with respect to the wireless network and the wired network. In all TCP versions, TCP/IP which we are using, the assumption is that the lost segments are due to network congestion, and in wireless it is because of high bit rate. Here there will be very little loss. It will be a very less lossy this thing. And here you will have, because the data communication and the data capabilities are very, very high, you will not have much of a problem with respect to the error and the loss rate. And here the session layer of the earlier, you know about this TCP/IP handshake, the three-way handshake, where you are talking to somebody, hello, I'm here. The other person says, yes, I'm here. And there is a three-way handshake. So that session protocol and all will not be there. It is more of an open standard. And all the handset and chipset makers are working towards this. And finally, the top layer that we see, the application and the presentation layer, which are combined here, it will give you the best service, high quality of service, less delay, less losses, high bandwidth, high reliability, good storage, good dialing. All these will come with respect to the quality of service. And that is why, if you see the quality of service parameters for 5G, they are entirely different from what we are going to see. The quality of service parameters are totally different here. Now, in terms of what are going to be the basic hardware and software building blocks. In terms of 5G, you're going to have ultra-wideband UWB networks with higher bandwidth at low energy levels. The bandwidth that you are going to get will be 400 times faster. I told you, you can get anything between 1 GB to 50 GB, depending upon the technologies. By and large, we are going to embrace CDMA, smart antennas. We are going to have a unified standard for the software in terms, now we have Wi-Fi, WiMAX, semantic web, unified MP, Bluetooth. All this is going to be subsumed into a single standard for the 5G. And as a result, we will also be able to implement SDR, software defined radio, software defined network, SDN. All these things will be there. Security will also be pretty much not compromised in the 5G rollout that we are going to see. This is again some of the pictures of the hardware that we are going to use. UWB, ultra wideband networks at low energy level, very high bandwidth, very high speed, using smart antennas and CDMA. I've already told you about this. We can go up to 50 Gbps itself. We will be able to ultimately reach. That is the plan that people say may happen. Then 5G will also be able to support virtual private networks. Have high. I already told you about the quality of service. All this I have already covered. Yeah. I've already covered all these aspects. High bandwidth, actually all this is already covered. Yeah. Now, coming to the justification, I had already told you the 5G rollout is very much needed for Industry 4.0, for cyber physical systems, so as to enable the smart aspects, whether it is a smart city or a smart education or a smart factory. So because of 5G, the applications will be multifarious. We already saw the Internet of Things. Your food, your medicines, your spectacles, your clothes, your shoes, your mobile phone, everything can be smart. And 5G will enable that. You will have pervasive global networks anywhere in the world. There is no interoperability problem. Your mobile phone will work anywhere in the world. There will be no issues. Media independent handover. There will be you can go for voice over IP also. Services will be very fast. And of course, the interesting sixth sense technology, even that will be more or less enabled as a result of these things. So this again is a slide. Again, this is pre-COVID times. I told you in the morning that COVID has completely accelerated the need for digital transformation. So this slide is predating the COVID time. So maybe all these numbers would have gone north, would have gone to the roof. But anyway, for the sake of academic interest, we are looking at 10,000 times more traffic, 10 to 100 more devices, more battery life, low cost, high transmission, high bandwidth. Perhaps we could also look at up to 50 gigabytes. That is what we are expecting with some of the 5G rollouts. Yeah. So this just is some of the use cases for 5G. We can control remote devices. We can have streaming services, media services. We can have streaming services. We can have all the things that I mentioned in the morning, the smart vehicles, the smart transport, and all these things may be possible because of the 5G rollout. Yeah, coming to the last part of the presentation. The last part of the presentation today, as I mentioned earlier, the 5G, the rollout, commercial rollout is not yet happened. Commercial rollout is yet to happen. At presently, we have a lot of test beds in various countries. including India, Europe, US. There are some test beds that are actively pursuing the research, tweaking with the technologies, and there are a lot of use cases also being developed with respect to these test beds using the 5G rollout. We have test beds in for smart transportation, smart logistics, smart automotive, smart health, smart agriculture, smart media, and so on. So we have so many test beds for that, and because of that, as mentioned, we have not reached a stage where we are having commercial services happening. There are no commercial services still happening, but in the research level, in the test bed level, there are a whole lot of consortia, there are a whole lot of research centers, universities, companies working at that level. Perhaps, maybe, I don't know, because of COVID, I don't know how much the ball has been the calendar has been affected, but we are hoping that at least in India, maybe early 2022, we may come to a stage where we may be having some sort of commercial applications, commercial rollout of 5G services and all. That is the expectation. Actually, I've come to almost to the end of the presentation. Anyway, I'll go through the various test beds that are presently available all over the world. Some of the this thing. One of this is the 5G TT program. This is a consortium promoted by the UK government. This test bed is 5G TT is a test beds and trials program. The idea is it is a massive government program coordinated by the government, where there are a lot of companies, there are universities, there are other stakeholders involved in a massive budget of almost 740 million pounds. And this is a test bed that is being developed in the UK. They are using local full fiber networks for this program. And the idea is it is to have a complete rollout of services, starting from smart education, smart healthcare, and so many different use cases are there. Another UK-based 5G consortium is the 5G UK consortium, promoted by University of Surrey, Bristol University, King's College, along with other partners, companies like Wireless, Cambridge Wireless, KTN, TM Forum, Digital Catapult, Real Wireless. So this is a private consortium, but at the same time, this consortium is backed by the UK government. It doesn't have that much of massive funding. It is 16 million pounds, but they are planning to have a full-fledged national 5G innovation network. And some of the test cases that are being discussed include, just give me a minute. Hello? WhatsApp WhatsApp. I'm sorry. Yeah. So this consortium has many different use cases. The use cases include a rural test bed, agriculture, smart tourism test bed, or then air air taxi services, urban connectivity, and so on. So some of the test cases that are being were developed by the 5G UK consortium are as follows. Now coming to the Indian test bed, the 5G test bed, the nodal agency is the Ministry of Electronics and Information Technology and the Department of Telecommunication. Department of Telecommunication is part of the same Ministry of Electronics and IT. The Modi 1.0, the first Modi government, there were two different ministers for telecom and electronics. Now it is one single this thing. The Department of Telecom comes under the Ministry of Electronics and IT, and they are already promoting this in India. The 5G test bed with a large project, several IITs, IISc is involved, IIT Madras, IIT Delhi, IIT Kanpur, IIT Hyderabad, IISc Bangalore, and the autonomous society called Samir, which is again promoted by the Department of Electronics. So the 5G testbed in India is now working on a prototype. It's more or less developed a prototype and testing platform for developing innovative baseband algorithms. It is a 5G consisting of several nodes. There will be nodes in these universities which will support this, and the frequencies are sub 6 gigahertz, and this is a massive project expected to be operational in 2021 with this thing of 221 crores. I think this is a little older data. I believe the whole project may be something like 1,000 crores or something. But at the same time, because of the COVID pandemic, it was expected that some sort of policy would have come in 2020. But unfortunately, because of COVID, I think this thing will be only likely to be operational in 2022, and maybe in 2021 we are likely to see some spectrum sale, 5G spectrum sale. We are likely to see kind of framework. Unfortunately, in India, the policy formulation takes a lot of time. Okay, it takes a lot of time. Unfortunately, that is the situation in India, because there is a lot of process, due diligence and due process. Several stakeholders are involved. Because why I'm saying is, I'm involved in the science, technology and innovation policy of this country. I'm in that one of the committees there. I'm actually a faculty ambassador for that, and the process is very slow. There are so many stakeholders that have to be involved. There are consultations, public consultations, feedback is there. There may be some vested interests also. There will always be pressures and vested interests. So the whole policy making gambit takes time. The entire process is not a very fast process. It takes its own sweet time. And perhaps optimistically, we can expect maybe by end of next year, at least some sort of spectrum sale we can expect. Now, if you see, Air India, even today, after 4 or 5 years before the government decided to privatize, even today it has not happened. Even today, the privatization of Air India is not happened, because once you give a bid, nobody buys, then you have to change the reference, then that has to go to the cabinet, then has to go to the line ministry. It takes its own sweet time. So I am only hoping that probably by middle of next year, we may have some policy. We may have the initial call for spectrum sale. We may, and probably in 2021 end or 2022, we may have a commercial rollout of 5G services by the primary service providers. That is what I feel may happen. It may take time. Having said that, some cities have already been able to, I think Berlin and 1 or 2 cities have had some commercial rollout, but it is not a complete rollout. It is more of a, what should I say, a market, what do you call that? I don't get the word. So more of a market, a test market rollout has happened. As we speak in Berlin and some cities, I think one city in Netherlands also has, the city has had a commercial rollout. But again, these are very few, and also they are very rare, and they are not on a mass scale. They are on a very more of a test marketing sale. So we have to wait at least a year. Probably by 2021 end, we may get a policy, we may get some first documents for spectrum sale, and probably in 2022 we may end up with an actual, we may be able to enjoy the benefits of 5G. Another example of a 5G prototype, EduRoam. Again, I think it's a consortium of American universities that are promoting this EduRoam technologies. I've almost come to the end of the presentation. Now when you come to the quality of service parameters, the performance indicators, so as to speak, they're completely different from what we have probably learned till now. There will be a total change. Now we are going to see new key process indicators, new quality of service parameters for this, and this is just a prediction of what would be the various quality of service parameters, a prediction of what could be the various QoS parameters, a prediction of what could be the various possible KPIs, key process areas with respect to the 5G rollout. And they are probably different from, pretty different from what we today know as the QoS parameters. So I've completed a little ahead of schedule. Yeah. So just coming to the conclusion, the 5G race is still going on. Commercial deployment of 5G systems is expected by the end of 2021. In India, perhaps 2022. Field trials are going on, but they are all not commercial yet, because I told you, as I mentioned, there are two things that are actually what should I say? Being a challenge is one, that the existing handsets cannot be used. You need 5G handsets with the new chipsets. Second thing, you need to have IPv6 services completely rolled out in all networks. That again has not happened. And when 5G comes, it is going to be a huge improvement in user experience, peak data, latency. You are going to have much high quality of service, high bandwidth, high speed, high performance, data communication, and all the things that are smart. Whether it is a smart city, a smart factory, a smart education, smart healthcare, smart devices will all be enabled. And we are also likely to see a host of value-added services like software-defined networks, SDN, software-defined radio, and so on and so forth. So these are being, and the spectrum and bands have not yet been finalized, but they will be in the gigahertz range. That much I can say. That some companies, there is slight variation in those spectrum bands. Here and there will be slight variations, but they have more or less agreed upon this. I think that's all from my side. I think this is finished a little ahead of schedule, but I am open to answer any questions that you may have. Thank you. Thank you very much. I think, yeah, over to the organizers.
Thank you, sir. Thank you so much. Now the question and answer session is open. I request participants, you may raise hand so that sir will answer your query, or you can open your mic after raising hand and you can speak. We welcome queries. I request participants, you may ask queries. You may post your queries in the chat box, please. Sir, there is a question from my side.
Yeah, yes, sir.
As you are a most informative person, is there any academic oriented research we can able to do in 5G, whether any funding is possible as far as you know?
Yeah, there is a, see, the as I mentioned, it may not be possible to join these. That consortium is a little closed network, but in terms of the the GISP forum and all, there are a lot of issues with respect to standardization and all. So in terms of standards and all. So there are issues, but those consortia you may not be able to join them because they are little closed in the sense that they are basically funded by the government, and once they get the funding, they may not want to share it with others and all. So there you may not be having capability, but still there are research issues, especially like I showed you just now, quality of service. See, we don't know what will happen when the commercial rollout is happening. So when that is happening, it's quite likely that we may be able to have better quality of parameters, quality of service, and so on and so forth. So such issues are there. We can probably speculate on various quality of service parameters. These are issues where you can work on in terms of research. What will be the quality of service parameters that 5G will be using, and so on and so forth.
Thank you, sir. Thank you so much. There is a question from Mr. Guru Charan. Which is the best protocol to send and receive data like MQTT, HTTP?
So every this thing has its own advantages. I mean, TCP/IP, HTTP. See, more than the protocol, I will say that the security is very important today. So my personal view will be that more than it is very important to go for secure HTTP, because we are moving more and more, transitioning more and more to the web, to internet, and so on and so forth. So more than speed, security is very important. We are doing a lot of e-commerce, we are doing online purchases, so it is better that we go for a secure protocol. That is probably the most important thing, going for a protocol that has the maximum security like HTTPS and so on.
Thank you, sir. Thank you so much. I hope the query of Guru Charan has been answered. Any other queries from the participants? Please raise your hand. There is an option is available in the Gmeet. Please, you can ask questions.
Yeah, one more thing I wanted to add. See, there is this global, there is something called the GISFI. That is the Global ICT Standardization Forum for India. So it's actually a civil society. It's actually, of course, there are academicians and all. You can just see, I'll put it in the chat box. Give me 1 minute. A Global ICT Standardization Forum for India. It is actually a civil society setup with not exactly under the government. It is somewhat, but it is supported by the government, and they are working a lot on standardization, specification. But let's see, like I told you, this is more of a what should I say, independent consortium. It is not part of the government. It is an independent consortium. There are companies, there are academicians, there are people involved, and they are also doing something. If you look into their website, they have some working groups, they have some research problems. So from there, you may be able to get involved in this global ICT standardization forum. But there is no guarantee that what they are going to do is going to be accepted by the government. Absolutely, there is no guarantee. A government may have its own priorities, but this is one way you can look for some research problems, some research areas in this field. gisfi.org.
Thank you so much, sir. Thank you so much for your information. As a member of Global ICT Standardization for India, I am proud to hear from you. I am also a member in the GISFI. To add to the information of Professor, there is a program is going to be conducted by GISFI this December via virtually, and they are going to open. We are still in test beds of 6G. What we are going to do is we are going to open the knowledge centric lab in Aarhus, Denmark, for 6G. Okay, already the 5G has been over. The amount of protocols, everything has been done. Already some countries has enjoyed the 5G because, as Sir told, the COVID-19 changed the length and breadth of the working style of all the peoples. Even some of us not even have a thinking thought of having a virtual STTPs, but this is the future. I will tell you people, this is the future. So we will be connected so that we can be get connected even in person who is working in US or UK via virtually through conference call or video call. Thank you so much, sir. This is the last call for the participants. If you have any queries, please kindly raise your hand or please kindly post your query in the chat box.
You can, if you want, you can even you can ask directly also. There is enough time. That's why.
Yeah, you can ask directly by enabling your mic, and you can ask. No, no problem. You can ask. Your questions are welcome. I feel I will be rather very happy if there is questions, and if more or less interactive session, I will be rather very happy. Kindly please participate and post more questions. And Sir has posted his email ID. You can mail him your queries. You can contact him. Actually, to be very honest, he is a very busy person. Since based upon my humble request, he has participated. He is not only an academician, but he is an administrator in Amrita Vishwapeetham. So he's a very, very busy person. I have to must thank him for allocating time once again for me and for the future phase 3. And apart from this, I just want to share you people. There is a special issue which has been launched in 5G system. I've been one of the guest editor. Any submissions which are welcome from you, research paper or research submission are always welcome. The date of submission is already expired, but there is a extension is there. Your submissions are welcome. Any good submission related to the topic, we are welcoming. So the journal is wireless personal communication, indexed in SCIE and Scopus.
I think there are no more queries. So
Yeah,
I think
thank
thank
so.
you. Yeah.
Yeah, I must have to thank you, sir.
Yeah, yeah.
One important thing, in future we are going to, we want to see you. We are not going to. We want to see you as a head for IEEE Madras section or in region 10, because once again I want to share every month newsletter when Prashant or Nair is a news editor in IEEE Madras section. It will be clean and precise. Now he is the editor for in IEEE India section. Now I am receiving through Navneet. It is very apt. Am I right, sir?
Yeah, yeah, yeah.
Yeah. So we want to see your participation once again in IEEE Madras section more, and want to be get participated, and your contribution and is needed for us.
Sure, sure. Yeah.
Yeah.
I would also want to come and visit the college at the earliest possible juncture when, as and when this COVID thing moves off, what to do. We couldn't travel and all.
We'll be
So
very
anyway,
happy.
yeah,
We
yeah.
will
I'll
be
also be
very
very
happy.
happy to come and sing. So, to the participants, I put my email ID. You can always connect to me. You can also, if you want to chat, or the email ID is, you may not get an immediate reply, but by the end of the day or the next day, I will definitely reply to you. And you can catch me on Facebook also. Just search for my name, Prashant R. Nair. You'll get me on Facebook. You can't join as a friend, but you can follow me on Facebook also. So we can stay connected through these means. Again, I thank Dr. J.N. Swaminathan and his faculty team for this excellent opportunity. Very, nice organizing, very effective and proactive organizing of this STTP. Wish the participants all the best and good learning in the sessions that are lying ahead. And of
Thank you,
course,
sir.
see you
Thank you
soon.
so much. I request to share your material,
Yeah, yeah. I'm just
PowerPoint
emailing it to you
presentation,
just now.
so that it will be forwarded to all the participants along with the recorded links.
Yeah, yeah. I'm just
Participants,
as I'm
yeah,
speaking, I'm actually emailing them to you. I'm
yeah.
sending
Thank
it
you.
from my Gmail because the size
Okay,
is slightly big. Just now, I'm
yeah.
sending it to you in 2 minutes. I'll send it. Okay.
No problem, sir. No problem.
Okay,
Thank
then.
you.
Bye bye. Bye.
Yeah, thank you, sir. Dear participants, thank you so much. The day one session is over. I hope all of you have enjoyed the day one sessions. In day two, morning, professor from Anna University, Dr. V.R. Vijayakumar, is going to deliver the lecture. And in the afternoon, Dr. Professor V. Venkatamani from NIT Warangal is going to deliver the lecture for the day two. I request all of you be present on time. If some of you have any connection issues, don't worry. We will send the recorded videos and the material for all the registered participants. So no problem. But one thing I want to remind you all, 80% attendance is very important for the short term training program. Your attendance will be taken in the Gmeet attendance add-ons, and apart from this, the certificate will be dispatched to you at the end of the day. There is no feedback session for every day. We will take the feedback at the end of the sixth day. Okay. Thank you so much. I declare the session is over. Thank you so much for your participation.